Okay, so uh, we are trying to find absolute extrema of function. So here you notice that in questions like absolute extrema, unlike the local or relative ones, um, we have to make sure that the function has any absolute extreme or not. And one of the conditions which satisfies or implies that the function will have absolute max mean is that if we consider it on a closed interval and the function is continuous on that closed interval. If f is continuous on AB, then f has absolute max and absolute mean value. If a function is continuous and you're considering it on a closed interval, definitely it's going to have an absolute max and min. Okay, how do we find it? Well, this is how you do. First, find the critical points. And evaluate the function at the critical points. Or let me just do this. Find the critical points in the interval AB. The ones that are inside AB, you may have other critical points. The function may have other critical points outside the interval. We are not interested in on those ones. We are only interested in the critical points inside the interval. Then add the end points. So the end points. So here the end points is A, B. Now, you will get a list of numbers. Maybe say you have 2 critical points inside the interval, and then you pick 2 ends of the interval for evaluate the function, all these guys. At all the points found in above steps. So you put them together, evaluate them. There will be finitely many numbers. Now look which one gives you the highest value, which one gives you the lowest value. So find the lowest value is the absolute mean the largest value is the absolute max. So this is how we find absolute max mean. Well, one of the ways. When the interval is closed, this is what you do. Okay, so let's then apply this one here. F is defined actually everywhere. X is defined everywhere, sine is defined everywhere, and is differentiable on the whole interval. It's everywhere, but let me just write on R, in particular on 0 to pi. Then that means that the critical points are the ones that f prime c is equal to 0. So you need to find the derivative, set it equal to 0, and solve that. F prime x is derivative of x is 1 plus derivative of sine x is cosine x. Set this one equal to 0. Cosine x, 1 plus cosine x is equal to -1. And then from there, you see that, okay, what are the values of cosine? What are the values of the angle whose cosine is -1? So x can be pi, 3 pi over, what I'm doing, pi, not 3 pi over 2. I'm working with cosine. Pi, or it can be 3 pi, or it can be minus pi, and so on. Basically, all odd, either negative or positive, multiples of pi will give you an answer for that equation. But we are not interested on all those ones. We are only interested in the one which is in that interval, 0 to pi. So there is only one critical point, which is pi in the interval 0 to pi. That is pi. How about the endpoints? Well, 0 and 2 pi. So just pick the endpoints of the interval. Now, the third one is that you evaluate the function at these points. F at pi, f at 0, f at 2 pi. F at pi is pi plus sine of pi. F at 0 is 0 plus sine of 0. And f of 2 pi is 2 pi plus sine of 2 pi. Sine of pi is 0. So the first one is pi. The second one is 0. Sine of 0 is 0. Sine of 2 pi is also 0. Now, instead of looking at a function on the whole interval 0 to 2 pi, you just look at these three values. F at pi, f at 0, f at 2 pi. Which one gives you the largest value? And this is smallest. So from this, the smallest one will give you the absolute mean. Well, sorry. Huh. I am not doing very good figuring out the smallest value, and 0 is less than pi is not that hard. Sorry about that. So f absolute mean value of f is 0, and absolute max value and what we found absolute extrema of the given function on that interval.